program is entitled the training or quick starts for the Fuji Portaflow-C portable ultrasonic flow meter. So for those new people to the world of ultrasonic flow meters, what is a clamp-on ultrasonic flow meter? What is all this noise about this technology? Well, the uniqueness things about this type of flow meter is that it is non-invasive. You just clamp on a sensor on the outside of a pipe, and it monitors flow on the inside of the pipe. That is the novelty of this technology. So you don't have to put a hole in the pipe. Nothing gets wet. Nothing makes actual contact with the liquid there. So as you can imagine, there's many, many advantages of having an opportunity to monitor flow with these ease of conditions here. And what it does to operate this device, it uses sound or ultrasonic frequencies to penetrate the pipe wall and into the liquid. What it does is it measures volumetric flow and total flow and velocity. But for the most people, they want to monitor how many gallons per minute I have and how many gallons that I use today. You can also monitor energy. You can add non-contact temperature to the equation. So that's for the advanced users there. It's ideal for spot checks of flow. So we're just put it on the pipe, say here's the flow right now, or you can leave it there for an extended period of time. So it comes in different shapes and forms, portable and dedicated. Today we're going to focus, of course, I said, on the Fuji Portaflow-C series there. We have made it very easy to use. Little to no training. Operation manuals, we have quick starts, are 1 or 2 pages long. And access to the equipment, you can buy it or you can rent it. So those are some of the values of what a clamp-on ultrasonic flow meter is. And how does it work? Well, an ultrasonic flow meter is very similar to this equation. And I have a man and a rowboat who would like to cross the river. And in this river here, the man's going to go from one side to the other bank of the river. The flow of the river is going from left to right. And when he gets into the flow, he crosses the river, it carries him downstream. It takes him a certain period of time to cross that river. Now, there's a current in the river, and when he comes back across the river, it takes him a longer period of time to transit the river. Well, the differential between those two transit times is a coefficient that we can use to calculate how fast this river is flowing. So just to repeat myself here, to go across the river, he goes with the current, he goes real fast, but when he goes back against the current, it takes him a longer period of time. The faster the flow rate, the greater the differential in time. So we use this to orient an ultrasonic transit time flow meter. And using a transit time flow meter here, we have some 2 cutaway windows here. And here's a traditional configuration, and this is a configuration which would look just like the man in the rowboat. Basically, we're sending a sound pulse across the pipe to the other sensor on the other side of the pipe. Flow's going from left to right. And then we send another pulse back to the original sensor, but because the flow is going from left to right, it takes a longer period of time to send the signal back, just like the man on the rowboat. In this case there, we're lazy. We're using 2 sensors on the same side of the pipe and ricocheting it off the back wall. Well, that's the reason to do that is it's convenient to see both sensors, and it's convenient to align both sensors. So life is just a whole lot easier when you can install it on the pipe in this configuration. This type of configuration is called the V, or the dual path configuration. And this configuration to the right is called the Z, or single path configuration. These are traditionally associated with pipe sizes. So for smaller pipes, say 1/2 inch to 24 inches, you will use the V configuration. And for larger pipe size applications, or applications that you don't have the required straight run of pipe, or applications that you don't have, you have really poor pipe wall conditions there, we would use this particular configuration. So we usually use it 24 inches and larger, or nasty applications that are shorter. Now the math behind this equation is what's really been the core competency for many, many, many years, and we're going to show you a flow chart in a minute there. But basically, we're looking at the differential time between the two signals to calculate your transit time. And what has evolved over the years, well, the core equation is the same, but we have more what-ifs, therefores. And so the technology's evolved dynamically, say, in the last 30 or 40 years. Long ago, when you had that giant big black suitcase that you had to open up and put these two huge pinging transducers on the outside of a pipe, well, those days are pretty much gone there. Back in those times, you only could use the basics of this equation, and if the sensors weren't aligned properly, you didn't put in the right sound speed, the right material, the right temperature, then the two sensors wouldn't communicate to each other, and you had to futz around with it to get it to work. Today, there's many value-added features and autopilot functions of this device to compensate for those old technologies there. So in most cases there, the ultrasonic transit time flow meter, and especially the Fuji transit time flow meter, is very easy to use and very user-friendly to operate. Now you can see under the cover, the math behind this whole thing of the going across the pipe or going across the river has a lot of calculations and why the earlier versions were a little difficult to work with. In this case there, we've got a sensor on each side of the pipe. There's a crystal at a specific angle inside that sensor, and it needs to refract this sound pipe at an optimum angle. This is why you can't exchange transducers with different brands. Everybody has a different angle inside their transducer. Well, the transducer will transmit through this pipe wall. We need to know the sound speed of that pipe, a liner if you have it, and then when it hits the processed liquid, it reflects, and then that's basically called Snell's law. Did you ever take a straw and drop it into a glass of water and it looks like it's kind of chopped a little bit? Well, it reflects there. We have to take that into account. We have to take into account the flow profile, the sound speed, and out to the other transducer on the other side. Mathematically, we know where the sensor is going to go before we put it on the pipe. In days of yore, all these things can affect the performance of the device, and today we have drop-down menus to compensate for a lot of these devices. So hard before, today operation manual, front and back piece of paper. Now, every ultrasonic flow meter, and for that matter, most flow meters in the world require a straight run of pipe, certain amount of straight run of pipe. We call that a symmetrical flow profile. And what it looks like inside the pipe with a symmetrical flow profile is the flow is at the fastest, the center, and slowest near the pipe wall. These different elliptical shapes are defined as Reynolds numbers. And what we're trying to do in this particular case there is get an average cross-section all the way across the pipe for optimum flow performance. So fast or slow doesn't make a difference, but if you have enough straight run of pipe, you'll have this symmetrical flow profile. This normally occurs 10 pipe diameters downstream from an elbow, put your sensor here, and another 5 pipe diameters before the next elbow. So that's your generic default for flow rates that are around 10 feet per second. Most pumped flows are between 7 and 10 feet per second, so that's pretty much your go-get-to straight run of pipe for optimum performance of your flow meter. Now, an asymmetrical flow profile is basically when you don't have enough straight run of pipe. So in this case there, I have my 90-degree elbow. Notice when the flow comes up through this elbow, I have a shorter distance here and a longer distance here, and I'll get a tumbling effect after this. If you were to put your ultrasonic flow meter right here, probably go into a fault condition, you wouldn't get any reading whatsoever. As you move farther down the stream, you may eventually pick it up, but it'll be bobbling around, so it won't be a very stable reading, and you may have to profile a pipe to get it to work. But when you get down to 10 pipe diameters, everything will be great. So optimum performance, 15 pipe diameters or 10 plus 5 is the perfect situation. Lower flow rate, less straight run of pipe. Higher flow rate, more straight run of pipe. Major obstruction, more straight run of pipe. If you have a valve or something invasive in the line there, a pump, you need to get farther downstream. So the neat thing about the ultrasonic transit time flow meter is it's a big math equation, and the flow meter does all the math for you. You just need to put in a couple of the basic variables. So in this case there, if I put in the pipe size, the pipe material, and the processed liquid, the device will calculate that this sensor should be here, and this sensor should be here, and the flow profile will look just like this if I had my proper straight run of pipe. Turn on the button, signal goes from here to here, everything's perfect, your optimum performance. Now, Should I not have my proper straight run of pipe, then the flow profile is distorted and may actually kick my signal downstream. Now, depending on how far it gets kicked downstream, I may or may not pick up the signal. So if I do my calculation what I'm supposed to, and I don't have enough straight run of pipe, and I put my two sensors on, and I get no reading, I will have to move my sensor or prospect my sensor, say in quarter-inch increments, to find that sweet spot. Now, once I begin to prospect for a signal, that means a couple of things. One, I don't have enough straight run of pipe. Two, there's an anomaly inside the pipe, a chunk of something, or the pipe's not round, so the math is off. Now, once I move off this button, the calculated space there, I may be able to get a reading, but it's not at the optimum accuracy that was quoted for this device. As you can see, in an application where I have a short run of pipe and I have a very wide range of flow, a very high flow and very low flow, the points of transmission across the pipe can actually be in multiple points there. So you may have to move your sensor as the flow rate changes there. So that's not a good thing, especially for a dedicated device. A portable device, I may get a phone call that, hey, I put it on the pipe on Tuesday, and then I came back the next Wednesday, and lo and behold, I couldn't get a reading. And the first thing we'll ask is, did the flow rate change? And they'll say, yeah. So did the point of transmission across the pipe changed, and because I had short run of pipe, that can be an issue there. Now, every application you see is not going to be perfect, and this usually is what I get to see when I get in the car after driving 100 miles. Here's a bad application like this. No straight run of pipe. So the customer will say, just put it on there, I just wanted to see it read. Step one, never show an ultrasonic flow meter not read on purpose. It's just a bad mindset, and that's the only thing anybody will remember. If you really want to monitor flow in this application, you have one choice or two choices. You need to go upstream or downstream, and somebody may have to get out a backhoe if you really, really, really want to monitor flow. Even a good application may require some attendance. You may have to use a ladder, you may have to use scaffolding, you may have to remove insulation off the pipe wall. So good applications, you may still have to work hard to get to work for your particular application. So where does this technology actually work? The ultrasonic transit time technology works in applications that have no suspended solids. The ultrasonic flow meter that requires suspended solids is an ultrasonic Doppler flow meter. Different can of worms altogether. Doppler flow meters are designed for applications with lots of suspended solids. So we use it on some wastewater, some sludge, and some slurry-like applications. The ultrasonic transit time flow meter is a completely different principle. Still some sound inside the pipe, but it uses transit time to calculate volumetric flow. So it works on ultra-pure liquid applications with no suspended solids. So, and it works up to about 2% suspended solids. So what does that mean? It'll work on deionized water, it'll work on jet fuel, it'll work on water, it'll work on sewage, but it won't work on sludge or oatmeal. Sludge and oatmeal, give that to the ultrasonic Doppler flow meter there. And since that's the minority of the application, the gut check for an ultrasonic flow meter today is an ultrasonic transit time flow meter used on, as I said, water, energy management facilities, HVAC, chemical process, water and wastewater, irrigation, leak detection, and many, many more. So in using this device, the benefits again are, one, we clamp it on the outside of the pipe. And the main purpose of having this on a portable device is that going through a spot check or a discovery process. I want to put a new chiller in my facility. What's my flow? Not really sure. Okay, you're going to go through the discovery process to find out what the capacities are, what the flow rates are, and in some cases what the energy is. So a nice device, simple to use, clamp it on the outside of the pipe, no holes inside the pipe, and to harvest your data or to store your data. And on top of that, as we said, it's very user-friendly to use. So what's it cost? Well, a portable ultrasonic transit time flow meter, you have a choice in some cases of multiple transducers, but most applications have a single transducer, and we'll see those in a moment there. The handheld device is about 5,000 bucks. A transducer is about 1,000 bucks. The base price for a Fuji right now is about $6,149 for a flow meter and a set of transducers. Purchasing it, capital equipment, rule of thumb, use it more than 3 months of the year, and it's probably better to buy the device. You need a piece of equipment for a specific project there, or you want to deliver it to this point someplace on the map, then a rental project might be a better methodology for you to use. You can rent them for like 699 bucks a week. The hardware. The Fuji Portaflow-C is about the size of a big voltmeter. Comes with a nice shoulder strap, so you can carry it up a ladder and down a ladder without dropping the device. Then when you do drop it, you can still catch it with the strap. You can put it around your neck, put it over your shoulder, and life is relatively easy. As I said, it's a lightweight device there. Battery powered, lasts about 12 hours. On the side picture here, here's our ports. We have a power port, have an analog port, and we have the transducer ports there. A nice big screen, full color screen to see that I can read without my glasses on. And on the bottom is where we store our SD card, where we store the data log information. And in addition to that, you want to go old-fashioned there, you can actually use a USB port to retrieve this data. The different flavors of transducers for the Portaflow-C. They do change the transducers every couple of years for whatever reason. They're getting better and better all the time, but you can still use a lot of the legacy transducers, which are pictured here on the left-hand side there. So they do have, there are on the drop-down menu, the different transducers here. Here's the most current transducers in the last year or two. Again, they just have less transducers that cover a larger field there. Here's the workhorse there. The FSSC does from 2 to 48 inches. And here we have the small pipe sensor, 1/2 to 4 inches. And we're going to look at those next there. For those people that have some giant applications, we have another 0.5 megahertz transducer and so on. Should you not have the latest transducers, if you had an older Portaflow-C and you purchased a new transducer, we may have to update the firmware so you can see the new transducers. It's a simple task that we can do during a calibration, or we can give you instructions how to do it yourself. The breakdown of the transducers, and this is really what separates the Fujis from the bargain brands there, is you need to have a device with multiple frequencies, and that is a sign of the intelligence and the signal processing of the device there. The FSSD is an adjustable small pipe transducer that is 2 megahertz, and you can use that, as you can see, from 1/2 to 4 inches. The FSSC is the workhorse. It works from 2 to 48 inches, and it has some special features I'll show you in a minute there. So it can do all the medium-size or middle-range applications there. And if you have some giant penstock applications, you want to go a couple hundred inches there, we have a 1/2 megahertz transducer on the FSSE. Not mentioned in here is the high temperature version there. Again, it does from 2 to 16 inches, but the price points are pretty high. It's about $5,000 for the high temperature transducer. Not an easy buy. Now here's the FSSC. The FSSC transducer, as you can see here, here it is standardly, but it has the ability to expand, so you can literally move some screws and it slides out and expands to a longer transducer rail. And in addition to that, you can pop off the 2 blue extensions there, and then you can have 2 separate transducer rails. So if you needed to do that Z configuration on that large pipe size application, it's all in one transducer. So very user-friendly from the breakdown of the V and the Z configuration there, and makes life a whole lot easier, one less thing to carry around. One of the big difference with the Fuji transducers and a lot of the other brands is that the transducer is one piece. So if you're doing spot checks, you can literally hand hold the rail on the pipe, collect your data, and you are done. You don't need to use the block and tackle method that some of the other brands have there. Some of the standard attachments we use for, if you want to leave it on the pipe there, on the smaller pipe applications, we use a reusable zip tie. Or you can use a regular zip tie if you have them there. Reusable zip ties, as life makes much easier there. You can use it again and again and again, and it's only available for the smaller line sizes there. Larger than that, we have a host of other options. The ratchet strap is very popular, and some people prefer some of the Velcro, and we used to have some felt cloth straps that we really don't offer anymore. So these are the three prime things that if you order a flow meter or you rent a flow meter, you'll get these with the associated transducers. They're also available as spare parts online. The OEM transducer that you get when you purchase the flow meter there is two segments of transducer cable that take you a section from LEMO to BNC, then BNC back down. And so in that case there, you can have an extended length of cable there, and it's a smaller grade cable. You can upgrade to the heavy-duty cable that we manufacture here. It's a heavier grade cable, so it's less likely to break. And comes in different lengths, 10, 20, and 15. We even make custom lengths if we need to. And it will have a BNC connector on one side and the LEMO or the meter head side connector on the other side, so reducing another jump cable should you need to have that. And for those that want to upgrade or have existing cables there, you can buy a BNC to LEMO adapter. So if, instead of having that extended cable there, you can go with the OEM version. You can just get this adapter, which are not inexpensive there, but it saves you another whole length of cable there. So let's get started in programming this guy. And we're going to break it down very simple because it is very simple. So the things you need to do before you play the game here is you have to have a little bit of data. So you need to identify your pipe size, your pipe material, your process liquid, and then we can actually begin to program the meter. So to go here, you begin by pressing the menu key, then you select Site Setup, and then you select Process Setting menu. Now on page 104 of the Process Setting menu, there's three basic parameters: the pipe outside diameter, the material, and the wall thickness. The OD is obtainable from our ANSI pipe chart book. You can download it from the website. Comes with the flow meter there, or if you had a thickness gauge itself. The thickness gauges are problematic in itself. They're measure thicknesses, but most of the thickness gauges out there will not measure anything other than the metallic pipe itself. So if you have some calcium inside the pipe, won't see it. If you have some gelatinous ooey gooey inside the pipe, it won't see it. To get your 1%-ish kind of accuracies, the ANSI pipe chart book is usually quite sufficient. So you need to put in the correct outside diameter. So if you're going to say, hey, I got a 3-inch pipe, carbon steel, like a 2x4. 2x4 is not 2x4 anymore. Look in the ANSI pipe chart book and you'll find out that a 3-inch carbon steel OD is 3.5. So here we put in this case there, you see the picture is millimeters, but if you flip the switch at the beginning, it'd be in English there. Put in the correct pipe OD. Then we have a drop-down box to put in the pipe material. There's a whole bunch of different materials there. You don't need to put the material sound speed in unless you had an exotic pipe. In most cases there, you're going to drop in, you're going to select PVC, copper, carbon steel, whatever, through the drop-down menu. And then we'll put in the wall thickness. Again, use the ANSI pipe chart book unless you have a testing tool. Then we move forward here. For typical applications using water and unlined pipe, you can skip a lot of this information here. But say you had a cast iron pipe with a mortar lining. There's really two choices. There's a single lining and a dual lining there. It's usually 1.25 is the traditional, or 0.125 is the traditional wall thickness for a mortar lining application there. We do not like exterior mortar linings with rebar under it. Not good, not a good application for any ultrasonic flow meter there. Also, we need to note there that we almost skipped there on 3.4, you need to select the type of process liquid. 95% of you will use water. Even if you have some mixtures there, a rule of thumb is plus or minus 10% of the sound speed, don't worry about it. The flow meter will optimize performance. If you look on the diagnostic screen, you'll see the sound speed changes all the time there. Kind of the autopilot function of the technology or the state of this technology, not so much with some of the older devices there. If you had a water and glycol mix, the traditional 30% glycol, 70% water. If you do the math on the sound speed, you'll find out that it's still within the plus or minus 10% of the sound speed. So 30% glycol and water, you can actually use water. If you had 72.5% glycol, then you may have to calculate it out and put the sound speed under other there. But for most cases there, almost everybody's application being water, maybe an oil, those are where you're going to stay from the drop-down menu. The sensor mount, most of you will use the V mount. We said we use that usually from 1/2 inch to 24 inches. You want to go to the Z mount, you would go then and press the down arrow and pull the next one up. So now, when you're all done, well, the next step I almost forgot, you select the type of the transducer. I remember there's a drop-down menu there of all the different flavors of transducer. And then you have the trans voltage. The trans voltage, there's 4 different settings of the trans voltage. And basically, as we send them out, we set them on the 2nd position. The only time you'd actually change the trans voltage is if you didn't get a signal, and that may occur on a nasty, nasty old pipe application. When you need a little more boost there, that's the time you want to bump it up to the 4th position to try to get a reading there. No, don't leave it setting on the 4th position all the time, because the more pinging you do with the crystal at high power, it will degrade it at some point in time. It'll shorten its lifespan to some extent. So put it back in position number 2. All done. Now we go and press the decision button, and then a nasty, nasty screen will pop up saying, after sensor installation, please adjust 0 point. The software of this program is designed by a bunch of little people in the laboratory wearing white lab coats and have no concept what's going on in the field. You cannot get a zero flow in the field unless you had a standpipe. And the way that this device is actually set up, the factory zero is excellent. Do not adjust the auto zero. If you do zero the flow meter in the field, you may actually insert a fudge factor plus or minus to your flow. So you basically, if you do that, reset the meter. The only time we adjust the zero on a meter is in an application we're in the 1/10 of a foot per second. So that's an exotic application, so we don't really adjust the zero. And underneath of that, it'll actually show the sensor spacing. This will go away. Sensor spacing will pop up, and that'll be the distance between the 2 transducers. Now we're going to get the transducer ready to put on the pipe. So we clean the pipe off, and what's required here is we basically, if it has some insulation, we remove a piece of insulation. We don't cut little holes or a little strip to put the transducer on it. We take off a whole section of insulation so we can strap it on the pipe there. And as far as prepping the pipe, a rag will do you, and if you got some loose rust, maybe a wire brush, but we don't use a grinder. We don't need any paint thinner to take the paint off or anything like that. If it ain't moving, leave it there. That's what the grease is for. The grease, basically, we put some grease on the face of the transducer, toothpaste on a toothbrush amount, transducer's flat, the pipe is round, it'll fill in the pits, and it'll convey the signal from the transducer through the grease into the pipe wall. So then the next step after that is we adjust the spacing that we just got from the program in the flow meter, which is the differential spacing between the 2 transducers. Now, if you have the choice on a horizontal application, anything other than 6 o'clock or 12 o'clock is your best bet, just in case you get some air on the top of the pipe, and in case you get some chunks of stuff on the bottom of the pipe there. Vertical really doesn't make that much difference there. So we determine the right site, we're prepared the transducer with the spacement adjustment, and now we go to install the transducers on the pipe. And if your transducer has adjustable knobs on them, in addition to going right and left, they go up and down. Nothing worse than getting a phone call and the guy can't get a reading, and all he has to do is tweak the couple of twist knobs there to push the transducer down so it's kissing the pipe. It needs to have a snug surface or mechanical contact of the actual transducer sensor to the pipe wall itself. Not the rail so much, it's the sensor. The rail's just there to help you make a measurement and make life a little easier. So we go and connect the cables to the transducer. The red is the upstream, the blue is the downstream. What if you flip them the wrong way? Well, instead of getting a positive reading, you'll get a negative reading, but everything is hokey dokey as far as flow rate, just to subtract or add that positive or negative, and away you go. So it only takes a few seconds to actually get your meter to read. Again, this meter is programmed in metric, but you can flip the switch to program it in English. And the way we send them out the door there, this GUI interface there, the top line would read flow rate, the next line would read velocity, and the next line would read totalization. And this would be the conditions. You can see it's in the normal mode there. Some neat features of this device is that it has the slickest data logger in town. And what I mean by that is it's this massive amount of data, and it has a short-term log as well. So if you're up on that ladder and guess what, you forgot your clipboard and your pencil to write something down, you can actually do a short-term log just by pressing the quick log button. And if you press that button there, it'll begin to log data there, take screenshots basically of the data that you have. It's preset to take a log every 10 seconds for up to 1 hour. So that's just a quick log if you don't have the ability to go in there. If you want to do the traditional log where I want to leave it here for an hour, day, week, month, whatever, in this case there, I need to go into the meter and set it up. So we begin this by going to the menu and to data logger menu. Then we select the position number 2 is logging. Now, once we're in logging selected, a next screen will pop up to input your desired named log. Now, this data logger will have an SD card, and it'll be 2 to 4 gig SD card, and it will store 25 million data points. So it'll log data until the cows come home. So the problem is, the first thing you do is you're going to get really lazy and not download your data all the time. So take a mind thought on future thought on how you're going to compile this data. So program the name of the file that's something relative to this particular project or location there, so you don't confuse it, because there's going to be a lot of data there if you don't take it off. So when you're finished, hit end and move on. The next step involves activating the measurements that you want. Again, if you had some of the older meters there that only stored 100,000 data points, the data you stored was critical because you only had 100,000 data points. Now you have a gazillion data points, so that's not a problem there. So it depends, again, what you're going to do with the data. You can go and log velocity, flow rate, total temperature. You can get into the energy side where you can recall BTU supply and return temperature and flow, and all those different things there just by checking off a specific box. So select that what you need, and she will log away. So we move into the mode menu, and we hit the right to move into the continuous tab, and now we press enter. For here, we can set the start and end time of our log. So the format that they use here for a clock is year, month, date, and it uses military time. If you're using a purchase meter or a rental meter, these are probably programmed on the East Coast time. So if you're going to use this on the West Coast, then you need to adjust the clock of this meter if you want it to correspond very specifically to your test. If you go and set the start and stop time there, that's fine. Make sure that you give yourself time to go and set this meter up, because if you go and hit the start button past that start time, it may take a year for it to kick in. And the interval, this thing will go as small as 10 seconds. Most flow logs, from a reporting standpoint, are traditionally sampled once a minute, but you can, if you have a special application, you can go faster than that. Remember, you're going to get tons and tons of data. What are you going to do with all the data? So you hit the start button, and now you're in the queue position, getting ready to start your log there. Once your log is finished, you can verify your logs looking at the logger data menu. You'll see the names of the log that you put in, and if it was a quick log, it'll say quick in front of it there. And all these files are stored on the SD card, which is at the bottom of the flow meter that we provide with the meter purchase or rental there. And as I said, it's stored as a CSV file. And so the next step is you want to get the data out. We have two ways. You can plug in a USB cable. It'll take a while to get the data out, or just pop out the SD card. If you don't have an SD port in your laptop or PC, guess what? We give you a USB reader right along with it. and that plugs into your USB port. Go to your computer, turn on Excel, and open this CSV file. No smokes, no mirrors, no software required to see the device there, and you're going to get your chart, all the information you want to manipulate. And if you want to add other graphs, again, it's in Excel. You can do anything you want with it. Life is much better. No cables, no nothing, and you may actually use your data logger. For our advanced users who want to measure energy, measuring energy is an option that you can add to the Portaflow-C. It has clamp-on temperature sensors, and the way an energy application works on this heat and cold supply loop there is basically a closed loop system. And so you will only need one flow meter, and most people tend to put it on the supply side because the Gazenta equals the Gazzetta over here. And what you're looking for in an energy monitoring is you need to measure flow, you need to measure temperature in the supply, and temperature on the return, and calculate the differential between these two, supply and return. So with all that data, we can come up with a BTU calculation, and of course it's stored on our data logger. So as we said, this is an option. It's the FCS Temp Kit option, and basically this involves connecting the strap-on RTDs, not wetted. I think that's the next thing to get over there. It's strapped on the outside of the pipe, which may be a degree or two different from the internal temperature of the process liquid. The key to BTU monitoring is accurate differential temperature. The actual temperature is secondary. So if you install it properly there, you can have an excellent BTU calculation done with a strap-on sensor. And so the way we do this, of course, we use a precision, very accurate RTD. We are not using an inexpensive temperature sensor. These things have incredible accuracies there, and when they come from us, they're calibrated as a matched pair. So it's plug and play. There's no calibration for you to do. You slap it on the pipe, and they're ready to go, basically. So in this case here, we would give you the strap-on RTD, and then the thermo compound with kind of like a zinc oxide to transfer this RTD temperature from the pipe surface itself for a metallic pipe application. And you put this on the pipe with a fusible tape. It's like a flexible duct tape that bonds to itself there, which stays there forever, or you can just use a hose clamp, whatever's convenient for you. So there's one on the supply, one on the return, and then the output signal from this device goes to your Portaflow-C in the analog input port. So we're now having the ability to log flow and temperature. So the key here is installation. If you're going to monitor and strap on temperature for BTU monitoring, plus or minus a few degrees basically messes up your information. It's garbage. So what you need to do is have an accurate set of RTDs that are matched pair, and they need to be installed like each other. So if you were to put one at 12 o'clock and one at 6 o'clock, heat rises, you could be a couple of degrees difference between these matched pairs when you start the ball game. And here, if they're both at 3 o'clock, they're both going to be at the same temperature, and you can monitor that performance before you start your test. So before you set up the energy functions with the FSCS, you need to choose your preferred temperature units. And this can be found on the site setup menu. Then select unit of output. The bottom two options provide your unit and total settings. Begin by going to the system setup menu and then select analog input output. Now, this is where you're doing temperature here, and this PS doesn't have to be temperature. We have people that put their pressure sensors in here as well. It's a fancy, fancy data logger with an analog input. You can use it for anything you want. In this case there, we're going to locate the analog port input and output option and toggle it from not used to use, and this engages the Portaflow temperature input. Once the analog input and output has been initialized, you can advance to input channel, and now you're defining it by selecting the supply for channel 1, and now adjust input channel 2 and select it for the return. So your data logger will be pretty because you've identified what those signals are. And as far as the range input, this should be pre-programmed by us, but if it isn't, our temp kit is designed that the base scale is 32 and the full scale is 212, and that's our basic defaults. You do not need to calibrate this device. It is ready to go out of the box. If you needed to go and have some unique diagnostics, this is for the advanced user. Most of the time, you don't need this at all. If you have a difficult application where you're having some interesting side effects there, you talk to support. They may ask to get some information here. To look at the diagnostic mode there from the main menu, would go to maintenance, then select transit time. And then here you can select the U wave, the upstream wave, or the downstream wave, and this would tell you whether we had a damaged transducer or a damaged cable, perhaps. So that's kind of shooting for trouble there, to look for trouble is. In this case there, we can also look at the transit time monitor. Well, here's a better picture there too. Again, most people don't need to use anything like this, but here we can do some better diagnostics if you have an exotic particular application. And then it really comes down to is what's your signal strength. Now, people put too much credence in the signal strength. Bottom line, you got enough, you don't have enough. You don't have enough, it doesn't read. If it reads, you got enough. So don't get excited about the signal strength like you used to do it a long time ago. Enough signal strength is all you really need for this device to work, and it'll begin to read. So detailed information, remember, it's autopilot, life is much easier, and things are friendly to use. So, talked again, too much as usual. What did we learn today? The basics of ultrasonic flow meter and how they work. In addition to that, we do require some flow hydraulics to make it work better. It doesn't always exist, and sometimes you're in the field and you have to do what you have to do. So if you don't have enough straight run of pipe, you go downstream about 2/3 of the available straight run of pipe and put your sensor there. That's the worst, the best you can do under those particular situations there. If you got some insulation, you got to remove insulation off the pipe for prepping this. Program it with good data. Give me the correct pipe OD. Not sure? Take a string, take a tape measure, take your belt off, wrap it around the pipe, and divide it by pi, 3.14. It's the only thing I remember from high school there. That'll give you the pipe outside diameter. Match that with the diameter that's in your ANSI pipe chart book that we've given you. We looked at the hardware. We looked at the transducer installation. We looked at the data collection. At InstrumentsDirect, we offer a wide variety of ultrasonic flow meters, but the Fuji Portaflow-C has pretty much been our go-to flow meter for most ultrasonic transit time flow meters because of its ease of use, its accuracy, and its economical price. So what we will do is we will record this training session and send it emails and post website in the very near future here. So there are other training videos on the website. All the spare parts we talked about are on the website as well. Our background, we've been in the ultrasonic flow meter business since 1977, so we know a little bit about the technology. Of course, we provide your services with sales and rental of this type of technology. We have a very, very in-depth support and training group there. Should you have a problem in the field, just give us a call. I'm going to give you the number in a minute here. And our support department would be delighted to help you with your particular application or your particular technical problem there. Maybe you need a calibration, maybe you need some service. They can help you with that as well. For those other people, for dedicated applications, we do have a sister company called Noncontact Meters, which is providing the dedicated ultrasonic transit time flow meters, of course, which you can also get them through InstrumentsDirect, as well as other type of flow meter technology. So, again, I've talked too much. I do have a couple of questions that Paul has pushed up here. People have asked throughout the program there that might be very helpful there. When traveling, the TSA took away my grease. What can I use as a substitute? Well, the grease that we give you is a silicone-based grease, is the standard go-to grease for the Fuji flow meter that we use. And it basically stays there. It's good for wet applications. It's good for higher and lower temperature applications. But it's a silicone-based grease. You're never going to paint that spot on the pipe again. We do have a water-soluble grease as an option, but that doesn't stay there very long, and you can wash your hands when you're done. That's our last choice there. In a pinch, when you've lost your tube of grease and you're traveling there, You just need any acoustic couplant for spot checking applications. And drugstore, pick up a tube of Vaseline or KY or something like that will pinch you through the short testing there. But mind this note, those substitutions are not going to stay there. They're for spot checking. They're going to melt, they're going to run out, and they're not going to have the viscosity as the silicone grease is available. So worst case scenario, just about any acoustic coupling will get you through your immediate test there. What is the minimum flow rate of the Fuji flow meter? This flow meter reads so low flow, we actually program it with a low flow cutoff of 0.1 feet per second. And the key point, when you're getting in the tenths of a foot per second, you know, you have to look at the application. You can't be going on a vibrating freight train at a tenth of a foot per second and expect to get a good flow reading there. But for most water-like applications, it's about the lowest flow rate you're going to get in any flow meter in the marketplace today. Many other manufacturers, the low flow is pretty fuzzy there. So a tenth of a foot per second is the minimum flow that we can really stand by. If you look at the data sheet, you see the accuracies published in that. And then the follow-up to, as I mentioned before, can I use the analog input port for other devices and log data? Yes, as we looked at the putting the temperature sensors in, they're going through an analog point. You can bring any device, any analog device through that port there, pressure, temperature, whatever you want to put in there, or you can just use the flow meter as a data logger. You don't even have to use it as a flow meter. So you got a fancy data logger there that's very easy to use. And explain the rental process. The rental process is very simple there. Well, we rent equipment by the week and by the month, and basically for the week you get to have it at your site for 7 days. The clock starts when you get it, and the clock stops when you send it back there. We provide the freight to any location, usually next day, or you can schedule a specific date in the continental USA. We pick up the freight, both round trips there, so you can get a next day delivery if requested it, and we give you the label to send it back. You can order it online, and of course you can call us here. So though there's some of the popular questions there, should you have additional questions about this, feel free to give us a call, and the number is posted on your screen. Drop us an email. And what we'll do is we'll leave the chat function open for a couple more minutes there for us to respond to that, and we'll conclude our audio portion of this program. We will drop you an email shortly as soon as we post up the version of today's webinar for your future reading or future viewing. This has been Brent Baird for InstrumentsDirect. Thank you very much for attending our session today.